Welcome to the Wonder of Stuff podcast, covering science, engineering and technology. From atoms to Android, zirconium to zoology, we'll cover it all here. Well, hello and welcome to episode number 10 of the Wonder of Stuff podcast. It's our birthday celebration, but I've got no little blower or anything like that. Broadcast live on Google Hangouts on air every weekend tonight, and probably going forward it'll be on a Sunday. This is the news, the place where you'll find news, information, commentary on science, engineering and technology from the past week and beyond, and anything else that interests us from inside our little human brains. As always, my name is John Gardner, and to help me out on this journey to knowledge, I've got my colleagues Richard Smith and Ross Davidson, and for tonight, our special guest, Andy Armstrong. Say hello, everybody.
Hello, everybody.
Hello.
Oh, the enthusiasm. Yeah, so I guess I better introduce Andy, and if anybody here is from a Perl coding background, they'll probably be using some of his code somewhere.
I should make a noise so I get the camera on me, shouldn't I?
Yeah, that's the one. Do you want to just tell us a little bit about yourself, what you do, what you're up to, and how we all got to know you?
Oh God, not especially. we nearly all used to work together, apart from Richard. Richard and I didn't overlap, but we were all colleagues. Back in the day when we were young and had hair. Which,
well, no, I never had hair then.
Something happened to three of us, and Richard escaped it. And we don't work together anymore, so that means that we're on speaking terms on a weekend. And I'm down in London now, playing with technology things. That's all you're getting.
Yeah, big smoke. Big smoke, BBC, big smoke. That's all you're getting. Right, well, let's just plough on then. Do you want to? We managed to make it to 10 episodes, and again, I've managed to remember to press the start broadcast button. So,
hey, it's a very podcast thing to keep saying that you've made it to 10 episodes. It's not that fucking many. Oh, is this family friendly?
No, it's not. It's no. You can say fuck.
Right, I'm going to mute my microphone now.
Okay, well, we're gonna get started this week with one of Richard's topics, and it's about mosquitoes. And well, I've got GM mosquitoes here, so there must be some genetic modification going on. Do you want to tell us a bit more, Rich?
Yep, there is genetic modification going on. This is the fight against malaria and dengue fever and other viruses and diseases, but this is a company called Oxitec, which is a UK company, which was why I was compelled to report this story. And they've already had some success with this. What they're doing is, well, there's been two efforts. One effort has been to genetically modify the mosquitoes so they have male offspring, which of course reduces the population. And similarly, Oxitec's efforts has been to reduce the population, and they're doing it by just killing the larvae. So both efforts are self-limiting. Because it doesn't pass down. So there's no real concerns about it, and it's been successfully. Obviously, it was lab tested first, but it's been successfully done in the Cayman Islands. There was 3.3 million mosquitoes released there by Oxitec, and that suppressed 96% of the native population of mosquitoes there. Wide scale, I don't have the numbers in front of me, but wide scale experiments have been done in Brazil as well. Successful there too. They're now trying to do it in the Florida Keys. It's a growing problem there. Climate change is thought to be at fault. The mosquitoes are now able to survive it further north than they were previously. So, and obviously it's a big thing. It's something that affects humans clearly. So we've got reasons to be concerned. However, with it being America, the problem is the anti-GM mob. So there was a poll done, I don't know if you've seen this, but there's a poll done recently about the Americans, and one of the questions was about GM. Is GM a bad thing? Should GM be stopped? And I think it was something like 57% of Americans think it should be stopped. So clearly very clueless on the matter. That contrasts with 88% American scientists who are saying there's absolutely nothing wrong with GM. There's no
how many of those Americans that were surveyed actually knew what genetically modified anything
Well,
was?
exactly. It's hard to say, but I think the concern remains the same: is that the scientific literacy of that population is getting further and further removed, further and further at odds from the scientific consensus as time goes on, which is quite alarming. You'd expect
So is that the same people who were surveyed, and 2/3 of them couldn't name a living scientist?
Yeah. I don't think it was the same survey, but I mean, during that survey, that they asked about, how many people believe in evolution, and the majority either believed that man was created in its current form, or otherwise evolution was guided directly by a supreme being. So, and that was the majority of people responded in that way. So, yeah, I guess it's not really that surprising, but it's actually putting the stops on this project. So,
there's another factor with GM crops which might be in play. We don't know what question those Americans were asked, but I think there might be a few who accept that GM as science is acceptable, but the way companies like Monsanto use it to engineer seeds that are effectively DRM'd, in the sense that they stop working after a generation and you have to go back to Monsanto and buy more. I think there's a group of people who take, amongst whom I would number myself, who take offence to Monsanto using the technology in that way. So if you're asking people, are you in favour of GM crops, it's not clear from the question whether you're talking about science or the commercial reality of companies using GM to make time-limited seeds. Things of that sort, which I think are a concern, but that probably has nothing to do with your mosquito story.
Yeah, in terms of this one, it's a change.org petition, and 130,000 signatures have been signed to try and stop the experiment. So it was just that I'd happened to see that survey coming out at the same time.
That's specific to this mosquito thing.
Yeah.
Yeah, it's actually quite pertinent, because immediately before I came on to do this tonight, there was a news story on about how dengue fever is now got in Greece and Spain. So, this would be perfect for yeah. What am I saying? This would be very good. That's what I'm saying.
I don't know. It's hard. It's like Andy says. I'm sure there's some valid objections. My own view is that if you asked some of these people what their basis was for that, I've got a feeling they wouldn't be that informed, and it would be more that we shouldn't be meddling, completely unaware of the fact that most of our food is already genetically modified in some way. So, yeah, it just seems a shame that the drift between scientific consensus and public opinion is getting larger in the US, I guess, is all I'm saying. But yeah, I guess maybe you could make the argument that the scientists have been too lax and the public are right to be concerned. I'm not sure.
But I mean, again, I think Andy mentioned it depends how you pose the question. You can load a question quite easily, and if that, I doubt I gather you haven't seen the change.org petition, so you wouldn't know what they've been asked.
No. Well, the change.org petition wasn't a poll. That was people have voluntarily gone on because they don't want this happening, because they're alarmed about meddling in nature and blah blah blah.
Yeah, but is the title of the petition? I mean, it could easily be, do you want bad things to happen or want them to stop? Oh yes, I want bad things to stop.
I haven't actually read the petition, but from what I gather, the analysis of the petition, it's not exactly scientifically sound. Important things have been omitted, and some stuff has been misreported, and some risks have been exaggerated. And I will take a look at that, though.
So, in terms of the original story of reducing the population of mosquitoes, if mosquitoes were eradicated, would that have what effect would that have on the ecosystem? Are mosquitoes mainly just an annoyance, or do they?
Depends on the species of mosquito. I think a lot of them are important pollinators and have critical roles in the food chain. I think, interestingly and conveniently, some of the ones that cause dengue fever and malaria in humans, some of those aren't critical parts of food webs, although we never quite, we don't have a good enough grasp on the biodiversity to say for sure. But I know this has been debated in the past, should we just eradicate certain species altogether? And that's hotly debated. But from what I understand, some of them, people say that some of them could be safely removed. So they're not as sort of interwoven into the food chain as you might expect.
So it's some mosquitoes or some other insects?
No, mosquitoes.
Mosquitoes.
There's not many species you could remove and not. But I think the fact that they're parasitic, they're kind of on a branch out there, aren't they? They're not, presumably they're prey items for something, so that would have an effect. But I think studies that have been done, some of the ones that are dangerous to humans, they could actually, they say, could be safely removed without impacting on animal populations too much.
Populations, I mean, it's interesting, but obviously you have to be careful of doing things like that, because obviously they're there in the whole scheme of things to do it. Now it may be that they are parasitic, but are they controlling a population of something else?
Yeah, it would be unprecedented that we've done that on purpose, but of course we've done it accidentally a great many times.
Oh yes, well that's what us humans do, isn't it? I mean, we're good at that. Putting our great big size 10s on it. Has anybody got anything else on the GM mosquitoes?
Well, I mean, the point you just made, John, is possibly the reason why, when scientists say trust us for scientists, the lay public, if you like, people who aren't enthusiastic about science as an end in itself, like we are, people who aren't science geeks. I think it is understandable, particularly in the US, that people would not automatically take on trust something that somebody who identified as a scientist said, because scientists are often in the employ of lobby groups who have a particular vested interest. You only have to look at climate science and see all the scientists in inverted commas who are prepared to turn up and say that there's no change to the climate and there's nothing to worry about. And it's not unreasonable, I think, of the public to be suspicious and not to be able to differentiate between what we would think of as good science and bad science, because there's a lot of disinformation out there. But I take the point that if it's a problem, because if science is discredited with people and people's knee-jerk reaction is to oppose anything that seems to be excessively sophisticated, like GM or stem cell research, or something that people feel has some sort of ethical dimension. The fact that scientists aren't well trusted by the public is problematic, right?
Yeah, I mean, I guess science probably does have a PR issue in many respects.
Well, science has a history of just sort of putting on a white coat and saying, trust us, we know best. And we know that sort of what we would call proper scientists, people who are doing pure research, generally aren't in a position to adversely affect the public, but there are plenty of scientists around the edge of the community who are just working for a company and will more or less say whatever they're required to say as part of that job. And that does legitimately breed distrust with the public, I think. I don't know what you do about it.
Well, interestingly, the one thing that they did have a consensus on, and the public and scientists did agree on, was the majority felt, of both the public and scientists, that science education was greatly inadequate in the country. So I guess maybe that's an element as well, I suppose. At least they agree on that. Maybe for different reasons.
That's right. I mean, I would hope that more people doing sort of citizen science and things like that, and the kind of we live in a period when it's quite possible to an unprecedented degree for people to do science at home. Set up some experiment that kind of possibly involves a Raspberry Pi or a camera or something. Because of the internet and because of the technology that's within people's reach, there's great potential for science to be democratized, so that lots more people actually feel that they have some kind of stake in the science game. They understand how it works. They get involved in an experiment or something and actually get to understand some of the experimental method. And until recently, scientists have more or less necessarily been stuck in research because to do anything useful, you needed, big machines, and lots of wires, and big budgets. And now that's not the case. It'd be nice to see science moving out into the community a bit more, being democratized. I know that's happening. Lots of universities are now doing sort of outreach courses that are available, I think, free of charge, distance learning courses, so anybody can pick up one of their basic science courses and do it. But I think that kind of thing is really encouraging, and it is a possible antidote to the general mistrust of scientists. What does everybody else think?
Oh, silence.
Not a great deal, apparently.
No, I mean, yeah, I mean, I think you speak sense, Andy. But I mean, yeah, but like you're saying, the distance learning courses and stuff. I noticed there was the MIT have put all of their. I mean, I'm talking. This is computer science here, but I think they're doing it with other sciences as well. But they've put all of their first and second year computer science courses, videoed them and put them online for free. And that's things like that is obviously a great step to helping access for other people.
And the other thing is the publishing of academic papers and the stuff that we all know about, the journals basically having a monopoly on really scientific research, effectively. I mean, there are now papers that sort of model themselves in an open source way, but people like Nature effectively have a monopoly on the cutting edge scientific research, which is a bit objectionable. How do we feel about that then? You're talking about what's it called, Aaron? What's his name? Who committed suicide? But the thing where he was downloading academic papers.
Oh yeah, Aaron Schwartz.
Aaron Schwartz, that's right. Yeah.
Yeah. I watched that documentary that came out about that. That was really quite interesting. Yeah, and he'd put a laptop in a cupboard, hadn't he?
Yeah.
And he was downloading all of the papers, and he was just going to make them available online. And didn't the FBI get involved?
Yeah, absolutely. It's nice to make an example of it. But is there not a moral case to be made that scientific research should be really available to everybody? It's the basic stuff of humanity. It's knowledge.
I think it's a huge issue because it's a feedback loop, isn't it? The problem that's occurring now is that there's so much emphasis on these glamour sort of science mags to publish the success stories that that's actually driving the scientific endeavour in that direction of that. It's just as important in science, isn't it, to report a null finding?
Absolutely, yeah.
It's often more important, but because of being glamorized by some of these journals that you mentioned, and because of the money associated and blah blah blah. It's a feedback loop, isn't it? That's driving the actual science to, a means to an end sort of thing. So I don't know about journal in particular, but I've heard that it's a big problem.
Yeah, basically people being encouraged to do research because it's going to sell copies of a journal effectively, because it's not just counting the number of flies that end up. There's a lot of boring research that's still valuable, but which doesn't make particularly good copy in, as you say, a high-profile science journal. And that's bound to skew the research.
Yeah, I think we've covered some of it on here. We've covered some of the fact that the boring stuff, like you say, doesn't get out there on non-scientific media channels, but is nevertheless a building block to something else.
Often, if you look at great scientific breakthroughs and track them back, and they're often built on that foundation, aren't they, of like negligible or no outcomes.
Experiment and getting something completely different out of it, and it taking years to realise that the anomaly that you saw is actually the coolest thing ever. But yes, that's right. Real breakthroughs don't happen as a result of some focused bit of high-profile, shiny research. They happen as a result of people staying in a particular domain for the whole of their life, effectively tinkering and messing around and throwing things together. And I think, more than just the question of which research is sexy, in a sense, the necessity to present some research at all probably has a chilling effect on it, because there's all sorts of stuff that you do that simply doesn't produce anything very presentable for a long time, but is still valuable.
Yeah, absolutely. Well, I'm probably going to leave that one there because I'm anxious of the time. But that is perhaps we'd do a one-off special on science, just generally. But the next topic we've got is going into material science, and it's about a new treatment for metal that a university has come up with to make it hydrophobic. Now, hydrophobic is basically to repel water. Now, we've been using metals for hundreds of years to build things, especially since the Industrial Revolution. But the main problem has always been rust, really. Once it oxidizes and the moisture gets into it, it starts flaking off. Up until now, whenever we've tried to stop this from happening, the barrier that we invariably come up with is a coating, whether that be as simple as paint or something like PTFE or Teflon, as it's known as, some barrier to stop the water from getting in. But the University of Rochester in America they think they've come up with something that's super hydrophobic. Basically, this is not a coating; it's a laser that etches a pattern onto the surface of metal, and it's a nanostructure onto the surface of this metal. But this nanostructure that they etch onto the surface actually not only repels water, but it absorbs light as well. So not only they hope that they will be getting no rust, less cleaning, and no ice buildup on these things, but the absorption of light is important as well, as most metals are shiny. So one of the other things, this is like it's been purported that this is some sort of major breakthrough, and it's a super metal, a super breakthrough in this area, and it's supposedly much more slippery than Teflon, to the point that if you put a droplet of water on Teflon, it takes, if you tip it up, it takes about 70 degrees before the water will actually roll off. So the friction is that in Teflon. But if you use this new etching, it actually, you only need to tip the metal up 5 degrees before the water it'll run away. It's also supposedly self-cleaning. They've actually done a test by they emptied a Hoover bag on top of this, full of dust on top of this etched metal, and it only took about 12 drops of water to actually completely clean the surface, and it still remained dry. What do you think of that?
That's pretty impressive. That, I mean, it's quite interesting that it's not something that's put on it. It's actually etched by laser. One thing that you mentioned that could be a side effect of this. You say it increases the absorption of light.
Yeah, absolutely.
Yeah. So could this be used for like making more efficient like solar panels? I suppose
that is exactly what they're pushing. Is one of the reasons. Yeah, that is exactly one of them.
Because obviously you want to absorb as much light as possible to get all the energy out. I suppose the other question would be: does it need to be a specific kind of metal, like a certain durability of the metal? Are they restricted in terms of what they can actually treat with this? Or
they're not. As far as I know, they're not restricted in the actual type of metal, but there is a restriction, and this is the reason why they're not in any way ready to release it to the public. And that the major problem is that it does take an hour to etch a square inch of this metal, right? And the laser is so powerful that the peak power utilization of this laser is equivalent to the entire power grid of the USA.
For a very short amount of time, I'm sure.
Yeah. It's 1 femtosecond or something.
Right.
But so they're having some production issues. But interestingly, to get to this stage where, and there was actually some videos and some images, and unfortunately I haven't got them. I'll have to put them on the show notes. But it's actually quite beautiful to see a droplet of water bouncing off this metal. But in order to get to this stage, on the research that they did previous to this, the team had blasted these materials with the lasers and turned them into a hydrophilic metal, which basically means they attract water. But they attract water in so much that the effect was that the water started going upwards, going uphill, as it were.
Right.
So not only have they got them to repel, but it's like virtually a water magnet, effectively.
Yeah.
You think of space exploration straight away, don't you, with that? Because how useful is that going to be for?
Or you could stick water to the wall or something.
Yeah. Well,
That's good.
Sounds like potential motion if the water goes uphill, but there must be a catch somewhere.
Oh, I expect so. Yeah, they're not very forthcoming with the actual because I was actually trying to see what was the actual the nanostructures that they were actually trying to etch on, but obviously they're keeping those fairly close to their chest, because no doubt they are funded by some like you were saying before, they are probably funded by some private company to do all this.
So when something's hydrophobic, then it specifically repels H2O, or it repels fluids. I mean,
it'll probably be any fluid, I would have thought.
Yeah.
Well, similar molecularly.
Yeah. It's interesting you mentioned about this of the hydrophilic attracting the water and it flowing upwards. There's if you ever watch videos about super fluidity, like superconductivity, but it's like fluid that at really, really small, low temperatures. When you get a super fluid liquid, it can pour out of containers, so it can overcome gravity and flow up the sides of containers and spill out of. So you can have a cup of liquid and it'll just sort of make its way out, which seems like anti-gravity, but just because of the way.
Oh yeah, it's like when you have a point chain in a container, and then if you have them, they did it on QI with the little balls and they'll attach, and it jumps a few inches out, doesn't it?
It's actually Andy has got those. He has got one of those ball. What do you call them, Andy?
One of those, I don't know.
Those ball chains that you've got on your desk.
Oh, magnetic balls. Yeah, you can. Yes, they don't do that particularly.
Do they not the one where they flow out of a?
No, that's just any chain. They don't have to be magnetic to do that.
I didn't realise yours was magnetic. I thought they were just one of those ball chains. Anyway.
You thought I just had a bit of bathroom chain on my desk.
Well, you showed me something with it, and I was assuming it wasn't magnetic, but obviously it was.
I'm showing you running down an aluminium channel, John.
You did. You showed me that, but we were talking at the time about the fact that where you could put them in a receptacle, and it would follow the.
Yes,
come out the top.
Yeah, maybe got to that.
Yeah. Okay, I've just stopped the flow of the entire conversation now. Thank you. I'll just shut up. I'm just going to fade myself out. Hang on.
Yeah. No, what I was saying before about space exploration, you can imagine how solar panels on the rovers or whatever, if you could repel fluid or attract whatever you want to attract and repel whatever you want to repel, imagine how much it would bring it forward if you didn't have to clean them. You didn't have to. There's all sorts of provisions have to be made to get the dust off stuff. It would be a massive thing if it just repelled dust, for instance.
I don't think it's so much it repels dust. I think just that because nothing sticks to it, the water, like John was saying, 12 drops to clean the whole thing. Yeah. It just takes it off completely because nothing's sticking.
It would make cleaning somewhat easier, though, wouldn't it, if you had that technology?
Yeah.
But I mean, there's more.
I was going to say there's in terms of, it was an interesting thing I was watching a while ago about a company produced one of these hydrophobic films that you could put on car windscreens, so that you wouldn't need to use your windscreen wipers because any rain would just go straight off. That sort of thing.
Yeah, well, actually, Pilkington have that for a long time ago. I remember seeing that on Tomorrow's World. But also, I mean, the problem with coatings or films that you have to put on is, of course, invariably they won't last very long because they are very thin and they'll have to be reapplied. This kind of negates the need to do that, or hopefully would negate.
They kill you immediately with cancer.
Well, there you go, Mr. Negative there.
So in terms of the etching on the metal, how durable is it? Like, you know, if you hit it with a hammer a few times, would water stick to it? Do they talk about that at all?
Nah, nothing like that. I mean, they're saying that it's that one of the benefits is because it's actually part of the same piece of metal. It's not actually stuck on. That it's more durable than any coating that they possibly have. But I mean, I was just thinking of more practical uses rather than in space. So I was just thinking of things like big pipelines, or bridges. Obviously, bridges have to be repainted every the fourth bridge, as it were, as we know. But you know, that could possibly stop having to do all of that.
Of course, if you're going to build the fourth bridge now, you wouldn't build it out of millions of tons of steel and big bits anyway.
No, that is true. That is true.
How long would it take to etch the fourth bridge if it takes how long to do 1 inch?
It's taking a square inch.
I do wonder in terms of pipes and stuff, if you coat the inside of a pipe, then presumably the conductivity of the pipe would increase, would it?
Yeah,
the friction would reduce, wouldn't it?
Yeah, so therefore the flow would be increased, wouldn't it?
Mm-hmm. And if nothing sticks, they wouldn't get clogged up with anything.
Yeah, but you build low friction pipelines by feeding the inside of it with that stuff. Yeah. If you need to build a low friction pipeline, it's nice when
something I do every day.
It's nice when your pipes run smoothly, though, isn't it?
It is, yeah, it is.
So you could have a frictionless hand job, could you?
That thought wasn't oh, dear. I think arguably the friction is part of the point, isn't
it? Part of the pleasure, anyway.
Isn't the friction is that job just thinking about it?
Shall we go to something else?
Quickly.
The next topic we've got on the running order is actually Andy's, and it's to do with quantum effects in plants. Now you were telling me about this earlier in the week, and it sounds really, really interesting. So do you want to just take it away and give us some info?
Yes, there was a two-part thing on the Beat by Jim Al-Khalili about quantum physics, and he devoted the second part of it almost entirely to biology. And the first thing that was interesting about it is it's always bugged me that apparently it is the case that we haven't really been particularly sure how photosynthesis actually works. And in the biological world, photosynthesis is the thing that seems really odd, that you can actually make stuff out of sunlight, essentially. We're sort of used to it happening, but it's still pretty odd to me. And it turns out that what they believe happens is that there's some sort of quantum entanglement thing going on. One of the problems with photosynthesis is that in order for it to work, when a photon hits a cell, there's a tiny part of the cell that it has to reach within a fraction of a nanosecond. Otherwise, the photon bouncing around inside the cell will dissipate all its energy. Photosynthesis won't work. And there's this theory, which, like most quantum physics, is utterly counterintuitive and completely baffling and impossible to grapple with. But the idea is that there's some quantum entanglement going on that means that when the electron hits the side of the cell, basically it makes a beeline for the right place without any messing, and dumps all the energy in at the point in the cell that it needs to be photosynthesis to occur. Now, the overarching problem with this, maybe Ross is down enough with quantum physics to help us out here, but like most quantum physics stuff, it's just mental. It's just
most of it is. Yeah.
The majority of science, you might not know it, but you can at least understand that there's nothing really odd and counterintuitive in there. You can know at least that all the Newtonian stuff obviously is pretty much observable. But most science seems okay until you get to quantum physics, and I'm afraid particularly entanglement just baffles the crap out of me and will not sit in my head in any satisfactory way. So maybe, Ross, you can say something that will put my mind at rest.
There was a quote from someone, I can't remember who it was, but there was a great quote that said, if anyone says they understand quantum physics, they don't understand quantum physics. because
Yeah.
obviously
It was Niels Bohr, wasn't it?
was it. It's
Yeah, I
a
think
lot
so.
of it is very baffling and counterintuitive, and like you say, Newtonian physics and science of stuff that you can see, it makes sense when you get the more details. It makes sense and it fits nicely into place, and it feels right. But obviously at the very small level, when you get into quantum effects, it all goes haywire. Basically, the whole wave particle duality of light is a strange thing. The Joule slit experiment, that doesn't make sense. But ultimately, it's on the quantum level that a lot of stuff has to happen on the nano scale, and it's one of these things. I think they're going to find a lot more of these sort of things that you think, so photosynthesis turns out to be a quantum effect. I think there's going to be a lot of things like that when they look at it in more detail that may or may not make sense, but it's an explanation. But yeah, I mean, the entanglement and the spooky action at a distance, that's always a one that can boggle your mind. So you have two entangled photons or two entangled particles with different properties, so opposite spin or something. You can separate them by an infinite distance, and looking at one of them, you observe its spin. That instantly makes the other one the opposite spin. So it actually affects the other one as soon as you observe it. So yeah, it's hard to grasp.
All very well saying those words, Ross, but it still doesn't. It still doesn't go. Oh yeah, I get it. Yeah, of course.
Yeah.
That's what happens. I mean, it sounds, on the face of it, tantamount to faster than light information transfer.
Well, this is the thing. I mean, it's my thoughts with quantum physics are the difficulty with it is that the reality is you can have an explanation for what's happening, and the explanation is exactly what's happening. Therefore, that's right. If you know what I mean. So something like the Schrodinger's cat. Everyone's heard of that, yeah?
Yeah.
Basically, you have a cat in a box, and then you have radioactive isotope that has exactly 50% chance of emitting a radiation, and if it does, the cat dies. And at that point, that cat is in this sort of what's called a superposition of being alive and dead at the same time. And it's only you opening the box and seeing whether the cat's alive or dead that actually makes it alive or dead. Now, the thing is, in my mind, well, it is alive or dead. But it being both alive and dead until you open the box is exactly the same. There's no differentiation between those two situations. Therefore, it's true. And you sort of have to accept it because a lot of these things can be exploited and then used.
Yeah, but it's uncomfortable just to accept a thing.
I know,
like that. It effectively sounds like an argument for authority. And there isn't, as far as I'm aware, any way you can intuitively get your head inside it and go, oh yeah, that must be right. Because it just doesn't seem to obey the normal...
You could argue the opposite though, because you could argue that we've now established that our common sense perception of the world is flawed in lots of ways. There's all forget quantum mechanics for a moment, but there's all sorts of analysis. The way we analyze risk, the way that we view chance. There's all sorts of things that we know empirically to be false. And then we know that our instinct isn't a good measure of what's true. And so quantum mechanics, in the Jim Al-Khalili documentaries, obviously these quantum effects predict everything. It predicts everything the classical physics predicts. But also, in the case of the photosynthesis and other examples that he gave, it predicts them where classical physics hasn't given an explanation. So it's just filling in the gaps. Obviously, quantum effects explain everything in the physical world, but it just, in the case...
I mean, presumably so, but there is a distinction there between the quantum physics case and things like our perception of risk and our general perception of the world. It's clear that we're not good at that, but there are easily understandable reasons why that is. It's because our brains are imperfect, and in abstract we can understand that and quantify it, even if when confronted with the effect ourselves, even an optical illusion or something, it still works on us, it still fools us. But For me, quantum physics is a different order of not understanding to just sort of being bad at assessing risk. Or
it is, but you can get there. You can get, everyone's different, I guess. Some people, no matter how much they're shown something rational, will still not act rationally. And there's certain things where you can be shown it and you believe it in principle, but you're just unable in the situation to act rationally. That's why I gave that as an example. And this, if you work at it hard enough, it does eventually come to make sense. Even though it just never matches your intuition. Never matches.
Quantum physics feels distinct from everything else in the sense that with everything else, I can at least sort of build a chain of inference back to something that's intuitive. And, this is where Einstein came unstuck with quantum physics. He didn't believe in spooky quantum entanglement. I understand. Russell, correct me if I'm wrong. And believed, in fact, that the more rational explanation was that when an electron was minted, it had this behavior pre-built into it, and all you were seeing was some sort of some event that was preordained at the birth of the electron coming to pass, which is what explained the apparent entanglement. And it's been proved, apparently, empirically, that Einstein was wrong. Actually, no, there really is entanglement. And almost singularly in science, that leaves me with no sort of... It's like, getting in a swimming pool, not being able to put your foot on the ground. There's no way for me to get... I do accept that that's probably a reasonable explanation because lots of clever people say so, but I can't actually construct the steps back to any known point and have the penny drop.
Yeah, I think I'm with you on that. I mean, obviously, I've studied a lot of it, but I knew the theory, I knew the mathematics behind it. I understood, the wave equation and how to use it. But yeah, the feeling of sort of, like you say, having the penny drop and sort of it fitting into place and it being the sort of like if quantum mechanics was just a more complicated version of Newtonian physics with more variables, it would be fine. But yeah, it's because it fundamentally feels not wrong, but it feels counterintuitive a lot of the times. And I think
it's just not the scale of the world that we evolved in, though, is it?
I think that's what it is. Yeah, I think
we don't have the equipment to.
We're not wired. We're not wired. We live in a macroscopic world, so we live in 4 dimensions, and getting your head around something that you haven't Newtonian physics, you experience that for your entire life, so it makes perfect sense. So.
Well, I mean, if you think that it's hard to grasp now, think about when I was 16 in GCSE doing GCSE physics, and they plonked right at the end of an entire syllabus full of Newtonian physics, the dual slit experiment and wave particle duality, and didn't say anything. Didn't introduce it. Didn't introduce it as this is a new type of physics or a different type of physics, and they just plonked it on the end, and an entire class just went, "What the fuck?"
But what can they do though? Because they're not going to explain it in terms that GCSE students are going to be able to get their head around during the course of the year's syllabus. But to leave it out, I mean, it completely outmodes.
The way to explain it is
you've got to mention it.
Yeah, the way to explain it is, you do all your sort of classical mechanics and that sort of thing, and then you say, however, everything we've just taught you is wrong. And then
Well, no, they're not wrong. They're just good metaphors, aren't they? I mean, to be honest, I don't think it's that distinct to other sciences that you see. Lots of times I hear people talking about evolution, they're actually talking about metaphors. Not how it works at all. People think they understand it. They're actually talking about metaphors. That's not really how it works. So I don't really, it's no different in that sense. That they're still good metaphors. They still work. They still describe accurately the macroscopic scale that we live in, and it still makes good predictions, and therefore it's correct in that sense, isn't it?
It's accurate at macroscopic levels. That's the thing, and that's all we need it for. That's the thing. You don't need to be any more accurate. You don't need to know that, you don't know exactly. If you know exactly where something is, you don't know how fast it's going, and that sort of thing. Well, on a macroscopic level, you can know pretty much where it is and how fast it's going. But obviously, at the nano level, uncertainty principle, that's impossible to know. But it only makes a difference at that level. That's the thing. So yeah, it's an order of rightness, basically. How right do you need to be right? It's
Well, the other example, I don't know, did he cover it in the show, Andy? I can't remember, but I know recently it's come out that robins are using, are aware of quantum effects at ambient temperatures, which is startling in itself. We used to think it had to be at sort of sub-zero temperatures. And
I don't know if they're aware of them as such. That would be really impressive. They might be able to explain it.
Well, aware in the same way as any, are we aware of it? I mean, that's a very philosophical question, I guess.
It's a shame it's not apparent, because then you might actually get an explanation out of it.
I don't think they're any more or less aware than any of their other instincts, put it that way.
I think it's the case, though, that Robin's innate compass, I'm not sure whether it's a magnetic compass at all, but basically the way that their compass works is something that happens in their eyeball, which is, again, some sort of spooky quantum effect that made my head scream.
But it's going to help us understand. There's all sorts of exciting things that it no doubt will start to explain about evolution. This will become an important.
I guess this is my practical problem with quantum physics, that I can't really use it as a thinking tool. And even though I'm not a scientist in most other domains, I can pick up a bit of science from some other domain and start to use it constructively, And because it's so weird, there's nothing you can do with this unless you. I mean, how the hell did they find out? How the hell did they find out that a robin was somehow fully quantum entangled in its eyes? Again, I mean, Ross, you'd be hard pressed to sit down and design something using quantum effects unless you were very, very conversant with specific, almost use cases already.
Yeah.
It's very hard to extrapolate from. It's not in your toolkit. You just go, I'll throw in a bit of quantum stuff here. I just need. I know what I need here. I need a bit of entanglement. That'll sort that out.
Well, I think we've touched on it before. The idea that the quantum computers and whether or not they actually exist or not. There's a company called D-Wave who do quantum computers.
They don't, Ross. They do and they don't.
Exactly. Yeah. Well, exactly. Yeah. But it's like, a quantum computer is being designed to exploit these quantum effects. And, the simple explanation of how a quantum computer works is that it works out all the possible answers at the same time.
Instantaneously.
And then picks the right one, right? So obviously it's fast. But it's like, how does that work?
You can actually sort of simulate that on a normal von Neumann computer. There's somebody did it's either an intrinsic thing in Perl 6 or something that did in Perl 6, where they invented quantum variables, which are variables that remember all the possible values they could have, and then you get a sort of geometric explosion as you do things on them. The variables that are derived from two variables that have all their possible values is the geometric product of all the possible values. So, of course, computationally it gets very slow, but apparently it's a simulation of how a quantum computer might work, in the sense that all the possible results are there, well, simultaneously when it's finished, Which is interesting, because at least it knows you to think about how you might program such a thing without having one.
Yeah, that's true. I mean, obviously, quantum computers, like I say, they could be brilliant for things that involve probability. I think that's weather forecasting and stuff like that. They'd be brilliant for.
So based on that, my understanding of specifically how a quantum computer would work would be if you set it to work brute force attacking some cryptographic secret, and say you had a 128-bit key, and you wanted you maybe knew what the plain text was, so it's not a very realistic kind of problem, but you would basically just sort of solve it for all the possible. You'd apply assuming it's a symmetrical cipher, you typically apply all possible values to your plain text, looking for your encrypted text, or vice versa. And the variable would end up sort of having the right value in it, because it's filtered on, it's a bit like a SQL query, I think, really. It's like select star from possibility space, where crypt x equals y.
Yeah.
Essentially, except it just arrives at the answer instantaneously, because it's magic.
It's very handy.
We're not allowed to say that on the science program. It's just magic.
Oh, you can say magic, yeah. It's all magic.
All I was kind of getting at was, I don't see how it's distinct from the scientific endeavour as it is anyway, because
I think
is science not about making good predictions? In which case, if it makes good predictions, it's not it's not suddenly that you have to start taking it on faith because it doesn't match your intuition. There's all sorts of things that don't match intuition. Yes, I mean Jim Al-Khalili says it in the program, doesn't he? That the next stage of this endeavour is to try and get it to, try and fudge it to match. But anyway, it doesn't really matter. If it makes good predictions, it makes good predictions, and
I think
it's right, and our intuition's wrong.
I think we should have a show of hands as to whether Richard's that doesn't really understand it. Yeah. He's not freaked out enough by quantum physics.
Well, but there's loads of things that I guess I'm just comfortable at not understanding something and taking a good prediction to be a good explanation device without needing to actually understand it, I suppose.
I think one of the sort of fundamental, if we're sort of saying is it fundamentally different, or is it just more of the same thing? I think one of the fundamental different things about quantum mechanics is that you're no longer dealing with exact answers. You start dealing with probabilities. Now you can't get an accurate, this is the answer to this question. You get an answer that says, well, it's probably going to be that, but it might be this.
But how is that different from a scientific theory, though? Because a scientific theory, you're shaving off and adding bits on all the time anyway. So it's never
you're getting more. It's never correct, but you're getting more. You'll get more accurate all the time. More accurate at measuring, or more accurate at getting the right answer. Whereas when it comes to probability, it's not. There is no answer. You know what I mean? So it is sort of fundamentally different.
Yeah, but it's still the practical application of it. I guess is that if it tells us how this, like Andy says, it's bugged us for a long time. How it's been very uneasy. How does this photosynthesis work in millionths of a second? And now it's given us an explanation for that because the maths predicts it. That's great, isn't it? Is that not?
Oh yeah, I'm not saying it's a bad thing. I'm just saying it's a different. It is different. It does feel different, and it does.
The photons in 42 places all at the same time instead of one. I'm happy with that. That's fine.
I don't
pretend to understand photosynthesis to any level beyond GCSE level anyway, so that's just another part of it that I don't fully understand. Great, that's great.
Well, yeah, it's all mindfuck to me, to be honest. I mean, I understand when I watch the program, I understand that the little chunks that were, this is a concept, great. This is a concept. I would have absolutely no fucking clue. I think pretty much what Andy was saying. I have no fucking clue how to pick that little concept up and put it into anywhere in my sphere of daily, tasks or knowledge or anything like that. I am, however, on Richard's side in that I am quite happy to know that that's a theory. That works in many cases. I'm happy to know that I don't understand it, but it's there.
I think it's turned into Room 101, hasn't it? John's just I think you can spell it in Room 101, Richard, or not.
I think quite honestly, there is no way we can get fucking quantum physics, the whole of quantum physics, in 45 minutes.
No, but we can just do it with little segments. Like I think it's the third time we've covered it, isn't it? And we've.
Well, yeah, because it's it interests me. I don't understand, but there's lots of things I don't understand that interest me. So that's
I find the philosophy of it. If you listen to some of the lectures of the philosophy of quantum physics, it's fascinating. And what they talk about, the experts in that field, is that's the direction the endeavour's heading now. Is will it come to a point where, look, we just got to give up on the fact that it doesn't match our intuition, but it makes better predictions than we can make with something that does match our intuition, or are we going to find a way to fudge it so that it matches? And I think Jim Al-Khalili said his point of view was that we will eventually find a common sense fit so that it fits and we're comfortable with it. But I don't know. I just feel as though that the science is the science, and then whether it fits with us, to me, that I feel uneasy that people need it to feel good, because to me the science is about it's about distrusting your own instincts and intuition and doing the science, and whatever the science tells you is true, and whatever you've thought before, you've got to give up on. Isn't that the scientific endeavor?
I suppose gravity and magnetism would both be pretty weird if it wasn't for the fact that they're so commonplace. I mean,
Well, even evolution would have been a difficult one when it first came out, wouldn't it?
I think evolution is easier than gravity. Evolution is, with the benefit of hindsight, obviously, is somewhat, that's going to be the way it works. If you can reproduce, and there's some chance that if you can mutate and you can reproduce, you basically have the prerequisites for evolution, and it's not, I think, actually, obviously Darwin gave us a bit of a leg up there, but it's not now hard to understand. But I think gravity is similarly counterintuitive, apart from the fact that it's commonplace. I mean, if we didn't learn about gravity as a sprung the first time we fell off something, we would find the fact that massive objects are attracted to each other also possibly pretty odd.
But it's not just, that could be anything. It's just because we've had all of these years to come accustomed to it. I mean, if I was in a lecture theatre when Michael Faraday first showed me a bulb being lit by electricity, I'd be like, fucking hell, he's a magician.
Burn him.
Yeah.
But like Andy's saying, you can get a common sense explanation that appeals to you, that is satisfactory, that explains that process, I guess, is the difference. Whereas with quantum mechanics, you get an explanation, but it just doesn't sit.
It still doesn't make sense.
Yeah, that's the spooky. That's where the spooky comes in, because it's it's like that uncanny valley thing, isn't it? When an animatronic becomes very close to it, just feels like this is not. There's something innate in me telling me no, that's wrong. And I guess even Einstein couldn't get over that fact. So it shouldn't make you feel in any way intimidated or inferior. Einstein obviously could not get over that, could he? So
yeah.
So anyway, here's a question about gravity, Ross. The film and the effect. When you're out in space and you've got the space station, and you're in your spacesuit, and you unwisely give yourself a bit of a push off spacesuit, and obviously what's happening is that you're achieving escape velocity in your local system, because if you don't achieve escape velocity, eventually you'll drift back to the spaceship, because there is some gravitational attraction between you and the ship.
Yeah.
So my question is, how slowly can you, how much of a shove how much of a jump can you risk taking on a spaceship before you'll achieve escape velocity and never come back?
A very, very small one, I would imagine.
I think you have to be a very cautious little, because of course this was the problem that they had essentially when it hit the asteroid, that its bounce might have almost given it escape velocity, and it might never have come back in an extreme case. But we don't. It just occurred to me that we tend to think of escape velocity as a local problem on the planet, and in fact, escape velocity is a concept anywhere where you have two objects that are attracted gravitationally.
Yeah. Definitely, yeah.
If you were really bored on the outside of the spaceship one day, you could play a game of Dare with your mate. I'm just gonna do a little stab like that and go,
Actually, there, Andy, did you mention the Aphelion Lander?
I did, yes.
Have you got something to tell us about the Aphelion Lander and its harpoons?
It's hearsay. This is based on a friend of mine who worked at the SA when they were in the earlier developmental stages of the lander. And he was saying that the way it works is it's designed to possibly have emergent intelligence when it hits the surface of the asteroid, because it's got various sensors, various systems that want to do their thing. But there isn't any overall control program that sort of says, if on surface, then fire harpoon. It's a lot more subtle and unpredictable than that. And there's this idea that possibly the reason why I didn't fire the harpoon is because it had already worked out by some means that the surface was so hard that if it fired the harpoon, it would, in the way that we just described, fire itself off back into space. Because if the harpoon didn't penetrate, it's possible that the inertia of the mass of the harpoon would certainly, if not give it enough acceleration to achieve escape velocity, would certainly throw it up so that the asteroid would rotate underneath it. And when it came back down, it might be in a less favourable place. So the idea is that, in all likelihood, the systems on the lander took a quick assessment of the situation, and while the harpoon computer was saying, fire, 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 the overall consensus that emerged was that it shouldn't do that because it would jeopardize larger mission. Now, I don't know specifically if that's what happened, as John pointed out when we talked about it earlier. That would require it to very quickly be able to assess the hardness of the surface it's landing on. We don't know whether it could do that. But the overall point is that it's not just following some pre-programmed recipe of instructions for what to do when it hits the surface. It's very much in real time and very quickly taking an appraisal of its situation, and various systems are competing with ideas for what to do in that situation, basically. So that was it. But quite interesting. So also the Mars rovers that have intelligent wheels, that's a similar collaborating systems kind of setup where the wheels are individually responsible for their own sort of health and traction on the ground surface. They can actually sort of vary their speed independently and raise and lower themselves. And that's really intelligence built into the wheels that's quite autonomously deciding how to do wheelie things without reference to any central computer.
I mean, it makes sense to have that sort of like, not I was going to say learning capability, but it's not really learning, it might be learning, I don't know, but that sort of autonomous nature, especially for the rovers, because obviously the drivers will program it to make a maneuver, but because you don't get real-time communication, it takes so long for if something happened, if it hit a rock and a rock slipped, it needs to be able to right itself, doesn't it? So
it's yes, that's right. It's also very interesting in technological terms. The reason why the wheels have to be so complex is because they don't have rubber tires on them, and it's really simple counterfactor trying to build wheels out of aluminium and not have them smash themselves up. But they need to have intelligence in them. And the reason why they don't have rubber on the wheels is because they can't risk taking any biological material any place they go. Because one of the first things that they're looking for is signs of biological material. So actually, the engineering of these landers is severely constrained because a lot of flexible materials that you would normally use are off limits. You know, anything that could harbour any sort of trace of biomass, you just can't use it really because you run the risk of contaminating your samples. And that's
so there's no way to decontaminate the rubber before you can't build it in a sterile environment and decontaminate it just before launch?
I don't know. I mean, I don't know what they use for insulation on cable. I mean, I assume PVC is okay, so rubber must specifically be problematic. To be honest, I don't know the details, Richard, but I understand that is the reason why they have aluminium wheels with no tires on to avoid, possibly because they're the ones that are in contact with the surface as well, which obviously makes it particularly...
It's very considerate of them. I assume when the Chinese go, they'll just say, fuck that.
Well, if they're looking for biology, they've got a problem if they...
Yeah, I guess so, if you want your readings to be accurate, yeah.
Yeah, let's hope everybody wiped their hands after they went to the bog before...
Just mentioning sort of like, the fact that it would be able to accidentally measure itself sort of thing. I was reading something this week, I think it was Viking or... I can't remember, one of the landers in the 70s that went...
Yeah, it would be Viking.
Viking, probably. It had a probe that was supposed to go down and measure the sort of hardness of the surface. And when they did that, they got some really weird readings. And it turned out that what had happened was it had like a lens cap or something that popped off. And the probe actually measured the hardness of the lens cap. So sort of accidentally measured a bit of itself. I thought that was quite interesting.
But I mean, I think the sort of artificial intelligence that we're building into the landers now, even 20 years ago, we probably didn't have anything like that. So.
Yeah.
Well, I remember they actually started working on it 20 years ago. So in some ways, it's necessarily quite old technology.
Yeah, I mean, even with the Rosetta probe, it was saying it was something only had like a 4-megapixel camera because that was. At the time when it was launched, that was reasonably state of the art.
But did anybody see what? Right, you're saying right to finish.
Well, we're sort of we're over an hour now, so we normally fit it in between now. But if you want to continue, Andy, that's fine.
No, that's all right. It's far too big a topic to start now.
All right. Well, thank you very much, everybody. Thank you, Andy. Thank you, Richard and Ross. If you want to get in touch with us, I've got the email address wonderofstuff@gmail.com was on the screen. Thank you
What
for.
I want to know is anybody watching. So if you're watching at all, let him know. Put him out in.
What I'm also curious to know is if we should do one of those polls. Do the American public accept gravity, or do the American public accept quantum physics? And that'll be an interesting. 99% of the American public do not accept gravity, so that.
Hey, there's no reason to just take it out of the Americans. There's some equally thick people in this country.
Actually, I put on Twitter the other day, are these very disheartening surveys, is it symptomatic of the American people, or is this just, more polls go on? If this poll was conducted in the UK, right, would it be better?
My wife, who works for a large international courier company, was in a training session with a few other people who worked for an international courier company, and were failed to spot that actually were pointing out that the country that they thought was America was in fact Russia. So don't the Americans do not have they're not the only ones who are thick. We have got a whole fair share of people who are quite happily living.
No, I never said they were thick. I just questioned their scientific literacy. That's quite enough, I think, to call them thick. I wouldn't have gone that far.
Oh, so now I'm the bad guy now.
Exactly, yeah.
Yeah, all right, fuck you.
You've gone too far, John, too far.
Well, I for one am glad it's descended into casual racism.
All right, well, thanks everybody again, and we'll see you next week at the same time, 8 o'clock, probably on a Sunday. So take care, and we'll see you.
Bye.
See ya.
Bye.